Okay, let's talk about a theorem that involves vectors. And this is what we call a unit vector that has a unit of magnitude of 1. So in the last video, we talked about a unit vector, or maybe we kind of need to clarify it a little bit. So we have a unit vector. Well, it's going to be kind of itself and its magnitude. Okay, so the theorem says that if I take a vector and divide it by its magnitude, I have what we call a unit vector. So here's kind of what I want to look at here. And remember that a vector, so just to kind of clarify a little bit, a vector, so we can call vector with that, remember it has a little arrow above that. A vector has both magnitude and direction. Okay, has both magnitude and direction. So remember, we can have a vector kind of like this, which is kind of like a V. We can have a shorter vector, which is another. Well, maybe you can call it U instead if you really wanted to. And then you can also have vectors that kind of go backwards. And so it really depends on the length of the arrow or the length of the vector that you can have, amount of current or amount of speed. In physics, we use force. Maybe you're looking at wind. So you have force, amount of wind pressure. You have what current. You're kind of having all these descriptions of what a vector is. But we're going to look at a unit vector and see what that's kind of about with this. So the theorem says if I take my vector and rewrite it, divide it by its magnitude, we can get what we call a unit vector. So let's kind of go through this here a little bit. So why don't we do a little proof? So let's do a little proof. Proofs are always nice to have. Let our vector be AI plus VJ. Remember what A and I and J are, correct? Those are those components. So if you want to recap, it goes in this. So your Y's are kind of like your J's, and your X's are kind of like your I's. Okay, and remember that I is 1, 0, and J is 0, 1. Okay, that's from the last video. So let's let vector V be AI plus BJ. And what we're going to do is kind of take this information, and then what we're going to do, then we're going to say, okay, let's take the magnitude of this. So let's take the magnitude of this. So remember what the magnitude is. We're going to take the square root, and we're going to put these in kind of a parenthesis form. So what we're going to do is take these two A and B, and we're going to go A and we're going to go B. Remember, we're kind of put I and then J. Well, then if we do some algebra here, and we kind of do this together, this is going to be A squared plus B squared. Now, we're probably thinking, well, what happens with this? Well, we don't really have it. This is it. This is all we can do. But what we're going to do is go up to what we're trying to do here, which is that we're trying to take our vector and divide it by our magnitude. So if we go backwards here, take this information and says, okay, well, we have our U, our unit vector, U, is equal to our vector over our magnitude. We will have, well, we have AI plus BJ, the square root of A squared plus B squared. Remember, this is kind of what we're doing here. Well, now you're probably thinking, well, what do we do with this? How do we split this up? Well, we can split this up, and I want you to know why. So if we make this equal, we're going to split this up. We're going to go 1s over A, and we're going to take the square root of whatever that is, I, and then we're going to add the next one. So we're going to go, okay, so B over the square root of A a squared, b squared, and j. So we have these two. So we're just breaking this up as two fractions. So these are kind of two fractions, but one is I and one is j. Well, thus, if we take the magnitude of these two guys here, if we take the magnitude of these two, well, I'm hoping that you get to see that this is going to be the magnitude of a squared over b squared plus b squared over a squared plus b squared. Now I'm hoping that you're see what I'm doing here is that I'm just taking these two expressions and kind of squaring them, kind of putting these all squared, kind of like what we did with this one up here with our vector, with our magnitude. So after you approach that idea, then you have something like this. Now, can we simplify this? Yes, we can. Since these have the same denominator now, we can combine them to be one fraction. So we can combine them to be one fraction. So if we do that, we have a squared plus b squared, a squared over b squared, because we can combine fractions here. Well, these are all squared. Well, if you take the square root of that, you're just going to have a plain and simple 1. So this is what we call this is a unit vector. Okay, so that's the definition of a unit vector. So what I want to do is kind of go through a couple of examples to kind of show you what are we doing here with this. And we can kind of continue here. So let's do some examples. And maybe I change the color here to help us out a little bit. So let's find the unit vector. So example, find the unit vector. So we're going to say let v equals 4i minus 3j. Okay. Now I kind of want you to see this a little bit. You can rewrite this as the vector of 4 minus 3i, or 3. This is the same thing. Remember, this is your I, this is your j. These are just coordinates. Okay? So you can rewrite that like that if you like. But we can leave it like this too. So the process is, so what we're going to do first is that we have our vector. Now I want you to recall that a unit vector is our vector and the absolute value of that vector, or not the absolute value, but the magnitude of that vector. So we kind of put this in the formula here, and we're going to kind of rewrite this, and we're going to write this as 4i minus 3j, but then we have to take the magnitude of this. So this part right here is that we're going to take the magnitude of this. So we're going to take the square root, and we're going to go 4 squared minus, well, plus if you really wanted to, minus 3 squared. And then we kind of do some math here. So 4i, 3j, and we're going to take the squares of both the squares of that, and that's going to be, is that 16? That's going to be 9, and that's the square root of 25, which is going to be 5, right? So take the square root of 25, which is 5. Well, that's kind of what we are kind of looking at here. But in textbooks, they don't want you to rewrite. They don't want you to leave it like this. They might want you to separate it out. And let's see if I have some room here, which I don't, but that's okay. Well, this is kind of the more professional way of writing. This is, you're going to go, well, 4, it's going to be 4i over 5 minus 3j over 5. This is actually the more preferable professional way of doing this. And if you don't like it like this, I mean, you can write it as 4/5 I minus 3/5 j if you want. These are the same thing. This don't matter. They're the same thing. And maybe you're thinking, well, what if I'm kind of skeptical here? What if I want to check? What if I just don't believe you? What if I want to check if this is actually a unit vector? Remember, a unit vector is just one. A unit vector is just one. Let's see. Let's take our answer and let's kind of check it. So what we're going to do is we're going to take these two values and we're going to square them. And we're going to square them. And we are going to check if it's equal to 1. Now, if you do some math here, this is going to be, let's see, that's 16 over 25. This is going to be, well, that's going to be 9 over 25. And that's 25 over 25, which is 1. So it works. So that's what we have. So that's how we do to get a unit circle, or not a unit, a vector, is that we start with a vector in the I and the j, and we want to put it into our vector over its magnitude, and it gives us our vector with our magnitude. And then we want to check it a little bit. All right. So let's end this a little bit with looking at some applications, because applications are always nice to see with this kind of this information. So let's do a couple of applications. So some applications with vectors. So let's do this. I don't want to get very specific here, but let's make a drawing. So what if we had a drawing and we went something like this, and maybe this was a ramp. This was a ramp. And maybe this was at 20 degrees. And you had a box, a weight called, let's see, this is like a, so maybe a box that's going up a ramp. Well, if you kind of look at this, a ramp kind of, gravity is always going to go like this. So here's gravity, always going a downward force. And you kind of go perpendicular to the ground here. So we kind of go perpendicular. And let's call this A over here. Let's kind of call this C over here. Let's call this D. Let's call this E. And what we're going to do is discuss, well, what are we trying to accomplish? How much does the piano weigh? Or not piano, but how much does the box weigh? So how much does box weigh? We want to figure out how much does the box weigh when it's going up this ramp. So let's kind of look at this here. Well, I don't want you to kind of get kind of distracted here. So let's make an X and Y table. Let's make an X and Y table. So X and Y table. Now on the unit circle, this is your sine. This is your cosine. All right. Then we have sine and cosines. And just to recall that X is your cosine, over theta, and Y is your sine. So what we're going to do is use this information to discover something about this. Okay, so you're going to set this up like this. Well, it's going to go up in the vertical direction of 20 degrees because it's moving up 20 degrees. You're kind of like maybe like sliding this up the ramp. Maybe you're pushing this up the ramp. So we're going to do sine of 20 degrees. Well, we want to kind of look at a few things here. Maybe we want the force. Maybe we want the force of the box. Maybe we want the force of the box, or how much the box, how much force in pounds, or something like that. So maybe this is 300 pounds. I know we said how much weight does the box weigh? I understand that. But let's, for example, this is not the weight. This is kind of like, remember how I said force? This is like the force to move that box up the hill, up a hill. So this is kind of like a force. That force it requires is 300 pounds. 300 pounds to push that box up that 20 degrees incline. So we have the force that we're pushing the box up this 20 degrees incline. Well, on the bottom, we want to figure out kind of this downward force. We have this downward force in which we can call gravity. So what we kind of want to do is find what that is. So maybe find that other force going down. And we don't know what that force is. We call it gravity, I understand that. But we have 300 pounds to push this up. We have this force pulling down. Well, can we take this information? So let's rewrite this as what we have. So this 20 degrees equals 300 over F1. And if we write this like this, can we take this information and solve for F1? Well, it's a proportion. So what we're going to do is just cross multiply. We're going to cross multiply, and you're going to get F1, equals, well, if we cross multiply, don't you going to get 300 over sine of 20? Which is roughly about 877 pounds. So if we take our proportion, we take the force that pushes the box up the 20 degree incline of sine of 20 degrees, because we're going in the the vertical fashion, and we're looking for how much does the box weigh. I guess that's what we're looking for, right? We're looking for how much the box weighs, because I want you to kind of understand the box is really gravity, because in physics, weight is mass times gravity. The mass, what's inside, times the gravity. That gives us our weight. So we don't really know the weight of the box, but we know it takes 300 pounds to push that box up a 20 degrees incline. Maybe there's something in that box. Okay, the box maybe doesn't weigh 300 pounds. Maybe there's something in that box, but you get the point. So that means if you do some math here, that weighs about 877 pounds for that thing to move up that 20 degrees incline. Okay, so let's do another one to help us kind of gather this information. Well, let's think about this for a minute here. What if we had kind of something here? What if we had something like this? So let's see. We have this. We have that. Maybe you need to move another. Let's say a crate. A crate up the hill. And let's call that 15 degrees. And it requires you to push, has some force. So let's do this. Maybe that crate takes about, I want to say 100 pounds of force. 100 pounds of force to move that crate up 15 degrees. Well, can we take our idea and find how much does the crate weigh? So crate weight. So the crate weight. We don't know what that is. We're trying to find that. So we're going to take our idea of this and kind of fill in the blanks here. So that's going to be sine of 15 degrees equals the 100 pounds and the force, which requires you that the weight. If you really wanted to, you could call this W for weight. It's up to you. In physics, they call it weight because force is really weight. You want to call it that. So if you cross multiply, so if we cross multiply here, so we're going to get, this is over 1. So if we cross multiply, that's 100 equals cross multiply here. All right, now remember we have to solve for F1. So you're going to go 100 divided by force 1 gives you the sine of 15. And you're probably thinking, uh-oh, I made a mistake. I'm supposed to solve. So that's the mistake I want you to see. So we made a mistake here. I want you to kind of see. You have to be very careful how you're doing this. So we want to solve for this. So we're going to divide by sine. So we're going to take 100 and we're going to divide by sine. It gives us the weight of that crate. And if you do the math here, so if you want me to show you how to do this, I can show you how to do this. So kind of any kind of calculator, you're going to go 100. You're going to divide, and it's in degrees. So make sure your calculator's in degrees, which mine's in radians. So I'm going to change that. Usually on most calculators, you just go to mode, and it should say degrees and radians. I'm going to hit 3. So now it's in degrees, and it should be up here. Okay. So then I'm going to be very careful here, and then I'm going to hit sine of 15 degrees. And that's things about 386.37 pounds. So I'm going to go ahead and do this. I'm going to go 386 pounds that crate weighs. Okay. So hopefully that made a little bit of sense. And I know that there's so many of these that you can possibly do, but it's almost the same kind of setup. And just remember when you're doing applications like this, just to kind of for your information. So let's look at a horizontal plane. Let's look at horizontal. When you're taking a box. So I always call boxes, but when you're sliding a box over, you're sliding it, well, kind of in the horizontal section. So just to kind of remember that this is going to be your cosine, but cosine times the vector. Be careful with that. So when you're going across the x-axis, you're going to use kind of like your cosine. If you were going in the vertical fashion, you would use sine of whatever theta b. So be careful. These are what the two applications you would use if you were kind of maybe carrying something up vertically. You would use this one. But maybe you're sliding something horizontal, you would use A. All right, so going just back, what we went through is that we went through the unit vector, which is just a vector of unit 1, or magnitude, I should say. Magnitude, remember, magnitude is kind of like your force. Remember, a vector has magnitude and direction. So magnitude is like your speed, if you want to call it that as well. Speed, force, whatever. Direction is kind of like your north, south, east, and west. So you need to have both of these for a vector. Okay, so I hope that helped a little bit. You just kind of need to practice these a little bit, and I'm hoping that they're getting a lot better. So I will see you on the next one.